So I built a simple multiplayer bingo website. It lets you add bingo tiles, and then when you're ready to create your bingo board, you click randomize and it'll create a brand new bingo board for you, and each one of your friends get a different one and you get to play against each other. Why did I do this? Well, the presidential debates were coming up and we needed a new drinking game, so perfect occasion for this. Hey everyone, today's video is going to be a little bit different. It's going to be pure software, so you don't get to see my mistakes along the way, which is good because I tend to break code with every single new line that I write, and that can get really annoying. Let's be honest, if you write 100 lines of code and it compiles just fine, then something's definitely going to be broken. So then you switch to Python, and then you get to watch your code break in real time and delete every single row from a database. Anyway, I'm going to save ranting about Python and different languages for a different time when I have a little bit more beer, but this time let's get right into the software. Quick note before we dive into the code, don't worry, you don't have to pause along the way and savagely copy paste everything from screenshots. I'm going to have all of this code put on GitHub, that way you can just download it, fork it, and do with it what you want. Yes, I really do have a story about someone who was copying screenshots. I'm going to start talking about the backend first. Usually I start with the backend, the model of the website. And that's just because I like to have data that I can work with while I'm building the front end. It helps me kind of visualize how things are going to look more. I'm sure bigger teams, they hard code some of that data into their front end while they're working so that they can see it. But I'm one dude and I just prefer to work on the back end first and then fill in the front end afterwards. So for my back end, I decided to use Flask because it's Python. It's super easy to build new things in. It doesn't have a very strict architecture around it, so you can just get started and start dumping code into it. Would I use it in production? Me, probably. Other teams, probably not. It really depends. If you're working with a large team and you're worried about folks being very diligent with how they write their code, you may want to use a different architecture like Django. What I'm going to do is I'm going to use Flask to take all of the bingo tiles being created by the players, and I'm going to save it in memory. If I was building this to be scalable and in production, I would use a database, but I'm not going to do that. I'm just going to save it in memory. One, because then I don't have to add a new system to this. I can just save it in a list or in a dictionary. And also because then I don't have to protect against SQL injection. And I know my friends, when they beta test it, are going to definitely do SQL injection. Bobby tables is their favorite thing to do. So let's start with those API calls. I know that I'm going to need to take those bingo tiles created by the players of this game, and I'm going to need to create, read, and delete those tiles along the way. Look at me, I was even fancy and used the correct HTTP methods. Yeah, HTTP methods to get that data. I'm so proud of myself. So I have enough in the back end to work with so that I can start building a front end, so let's go do that. I like to use React. It's a little bit weird when you get started if you're not used to doing front end stuff, but once you're there, you can build pretty cool websites pretty fast. Now this whole app, like most React apps, is one page. And what I do is I construct it in different components because I like to build things very modular. That way I can swap out components, I can move them around. It's just how I like to work. And I think you'll find that if you do the same kind of structure in your programs, it will help you be able to update them better in the future. Okay, let's take a look at just one user story, and we'll start with the most important user story, and that is how does a user add a rule to the game? To do this, the user will type in the rule that they want to add, and they'll click the add button. When the button's clicked, we trigger an onSubmit event. This can be the onClick event too. I'm experimenting around and I don't quite know the difference yet, but if you do know, let me know in the comments. Anyway, when the event triggers, we call the add rule method. That pulls the rule text out of the React state. But how does the rule get into the React state in the first place? Well, if we go and look at the input element, you can see that as a user types in the rules, I'm saving that rule to the React state with each character stroke. After some beta testing with my friends, I added some basic checks to make sure the rules being added are valid and not just 1,000 spaces long. Yeah, they really did that to me. Thanks, guys. Then I put the rule into a JSON format and I call a different method to ship it off to the backend. Okay, now let's hop over to Flask and see what happens when it receives that data. So there's an API add rule function, which receives that data first. unpackages it, and then hands it over to the add rule function. So why do I have two? Well, I like to really break functions down to one simple thing, right? The API add rule function is just going to unpack it and prepare it to send it to the normal add rule. A good reason to do this is if you're doing unit testing, it makes it easier to find bugs in your code. Also, it'll allow you to expand in the future. Let's say I want to do some automation where I add rules. It'll be kind of weird if I just have that API add rule and I kind of hacky find a way to push JSON packages into it. It's just easier to separate that out at the beginning. Okay, the first time you try to deploy all this, you're going to get a failure. Front end is going to try to talk to the back end and it's just not going to work. Why? Because of CORS. No, not CORS, CORS. Cross-origin resource sharing. So what you have to do is you have to let the back end know that there's this front end website that's going to make requests from it. And those two are allowed to talk to each other. It's a way so that you don't just get random folks on the internet trying to pull data from your backend. It just lets it know that this is a safe domain, or in my case, IP address, because I didn't want to register a domain for this. With Flask, this is pretty straightforward. I use Flask_cores, which is a package that you install, and I attached it to the Flask app. I just left it wide open. Don't do this in production. Like I said, this is all pretty hacky and put together quickly. I don't really care if somebody tries to maliciously attack my bingo games. Now that we've opened up the gates, front end and back end can talk to each other. Now, if I'm on my local host, that's not a problem because the addresses aren't going to be changing. But as soon as I start deploying this in the cloud or on other machines, I'm going to run into a problem because I have to change the IP address constantly for the two machines to know how to talk to each other. So what I do is I have a constants.js file. So in my constants file, I have a dev and a prod URL. And I've created a token in there that I can swap out. It's just called prod URL. And I actually use a script when I'm deploying this automatically. I swap out the token with the cloud compute's IP address. Now, if we look at other places in the code, you can see how I'm using this. When I create the components, what I do is I'm passing the base URL into there. So if I'm in dev, it's always going to be localhost, but when I'm in prod, it's going to be whatever IP address I've replaced that token with. Now, when I make API calls, I use a base URL and I add on to the endpoint that I want to reach. Now let's deploy this all on AWS. This is not going to be fancy at all. It's not even going to be close to how you should actually do this. In fact, really, I should host the front end on S3, use CloudFront to deploy that across a bunch of different regions, maybe spool up Kubernetes, and have my backend running in there, but we're not going to do any of that. It's way too much. All I'm going to do is spool up one EC2 instance and an elastic IP address. That's all we need. Okay, I lied. One more thing. We need a security group. So the security group is going to set up the rules for how this EC2 instance is able to talk to the internet. We're going to want to allow traffic to come in to the ports that the front end and the back end are using, but I only want to allow SSH access from my machine. So that's kind of an important thing you want to do. It just helps keep things secure. And if you don't have a VPN, it's just the easiest way to go around it. Big companies, they have a VPN, you log in through that. But in our case, one dude operating out of my house, I don't need anything fancy. Just hard code my IP address in. Like any good programmer, I'm pretty lazy. So anytime I have to automate something, I'm gonna do that. And this program was no exception. I created a Ansible script to automate the deployment of this app. If you haven't heard of Ansible before, super useful. It's just a really quick way to script deployments out. Highly recommend that you get started learning it. So what my Ansible script does is it spools up an EC2 instance, figures out what that public IP address would be. Then it connects to GitHub, clones the repo. It'll change out that token with the public IP address of the instance. It makes sure, of course, that I have all the correct packages and libraries installed, including Screen, which is going to be very important. Anyway, the script can pretty much handle all of the installation of the program. It just can't start it. And that's because I made a mistake. I really should have packaged these up as Docker images and used that to deploy this all, but I messed up. So really just everything set up for you, and then it's like 2 minutes for you to actually start up the front end and the back end, and then it's deployed. All right, so the hack solution. I'm gonna run each service in its own screen session. my Ansible script already installed screen, so let's start a new screen session called backend. And in there, we'll start the app.py file. That's the main Python file with all the Flask code in it. Okay, now that that's running, it's safe to start the front end so that I can start reading from the back end. We'll make a second screen called front end, and we'll use npm serve as opposed to npm start this time. This node package just makes it really easy to serve static files. You can even serve folders using it. Anyway, generally, the front ends are static file sites, so that's why serve works in this case, and also why you can actually host a React website using S3. I haven't done it yet, but I should probably do that. In the future, it's going to be way cheaper to do that than to spool up an EC2 node and have it running constantly. Okay, and that's it. So both the front end and the back end are up. I can just go to that public IP address, and there's my website. If you're still here, thanks for sticking around. I know this was a bit dense. I covered a lot of different things, and also it's a different topic, but it's something that I like to do as well. And this channel's pretty much just about my hobbies. And once again, if you want to check out the code, I linked the GitHub repo in the description below. Go ahead, check it out. Also, leave me comments, tips, hints. I'd love to learn how to do anything better. And if you're a coder, I know that you have opinions. Let's be honest, you've done code reviews. You just want to stomp all over my hard work. Okay, it's time for me to get started on the next video. Thanks, until next time. Yes.